Hello, welcome to 5.2 Verifying Trigonometric Identities. We are going to start with the first few examples. So let's look at example 1, secant x times the quantity sine x plus cosine x, and we're trying to show that that is equivalent to 1 plus tangent x, and that's for all x values that work for all these functions. So the key to verifying is that we need to start with one side, and we're going to manipulate just one side to make it equal to the other side. So one strategy is to choose the more complicated side. In this case, it's pretty obvious because this has three different expressions. It has parentheses, whereas this is just one function added to one. So we'll start with the left-hand side. And the way we denote that is LHS for left-hand side. That means we are showing our readers that we are working just with this side over here. So we have a couple different options here. We could first distribute the secant x, or we could right now write everything in terms of sines and cosines. I'm going to go ahead and distribute first, and then we will likely put things in terms of sines and cosines. But let's see what it looks like. So we're going to multiply the secant x by sine x, and then the secant x times cosine x. Okay, so no Pythagorean identities are screaming out at us, so we're going to go ahead now and rewrite secant x in terms of cosine. So we'll rewrite secant x as 1 over cosine. So remembering when we multiply fractions, we can always write the expressions that are not fractions over 1 if we'd like, and we'll go ahead and multiply the top times the top and the bottom times the bottom to simply get sine x over cosine x here and cosine x over cosine x. So now we can observe that sine x over cosine x is in fact tangent x, and any expression divided by itself is going to be 1, so we get tangent x plus 1. And now is when we say, okay, now let's look at that right-hand side to see, are we close? Oh yes, we're very close. In fact, tangent x plus 1 is the same as 1 plus tangent x. So we can now say that equals the right-hand side. So what we just showed is we took the left-hand side alone, and we just worked with just the left-hand side to get to an expression that is clearly equivalent to the right-hand side. Okay, example 2, cotangent squared x times the quantity tangent squared x plus 1 equals cosecant squared x. So again, we have to identify which side is the more complicated side of the equation. So that's again the left-hand side here. So we will start with the left-hand side, denoting LHS for the left-hand side to show that we are working with this side here. One thing we want to look for is, are there any Pythagorean identities in here? And that's one of the things that will really help if you can identify those early on. Sometimes we don't identify them early on and then they will come up later. That's fine too. So if we go ahead and say, oh, there's something with a tangent squared. So there is an identity that says 1 plus tangent squared x equals secant squared x. Aha! So if we have a tangent squared x plus 1, now we can go ahead and replace it with this secant squared x. So that's going to give us cotangent squared x times secant squared x. Now this looks more promising because here we had two terms and here we now only have one term all multiplied together. So that's good since our right-hand side is only one term. So now what to do? we can, because they're both single expressions here, let's go ahead now and turn everything in terms of sines and cosines. So cotangent can be written as cosine x over sine x, but because the cotangent is squared, both the cosine and the sine will be squared. And then this is multiplication still, and secant can be written as 1 over cosine x, but because the secant is squared, the cosine will be squared. Aha, now we see the cosines will end up canceling because we have a cosine squared x on top and a cosine squared x on the bottom, and we are multiplying, so those will cancel out. And we are left with 1 over sine squared x. So we get cosecant squared x. So notice that's now our right-hand side. So we have shown that the left-hand side, only manipulating the left-hand side, gives us that right-hand side. There is another way we could have done this problem, which is first distributing the cotangent squared to both the tangent squared and the 1. So in that case, we would have gotten cotangent squared x times tangent squared x plus cotangent squared x. So this is not looking super simple, but I just want to show you that this is also an option. So now if we write everything in terms of sines and cosines, we'd get cosine squared x over sine squared x. Here, sine squared x over cosine squared x plus cosine squared x over sine squared x. Now let's simplify. In this situation, our cosine squareds cancel, but also our sine squared cancel. So we end up with just 1. Over here, we end up with, we have cosine over sine. So we could rewrite that as cotangent squared x. So that's this, just going back there. This rewriting cotangent in this case didn't end up being very helpful. But now we might observe something here. We have 1 plus cotangent squared x. And there is another Pythagorean identity that says 1 plus cotangent squared x is cosecant squared x. So now we can use that identity since we have exactly the left side of that identity. This is in fact equal to cosecant squared x, which is that right-hand side. So notice we did two pretty different techniques, but either way, they both got us to the same answer. So both of those methods are perfectly acceptable. Example 3. Tangent squared s divided by secant squared s equals 1 plus cosine s times 1 minus cosine s. Since the left-hand side does in fact have a fraction, we will go ahead and start with that because that usually indicates a more complicated side. And what we might notice right here is we have an option. We could either use the Pythagorean identity, or we could go ahead and write everything in terms of sines and cosines. Both are viable, so I'll go ahead and do sines and cosines. So I'm going to rewrite tangent as sine over cosine. So I get tangent squared s is sine squared s over cosine squared s. And then I will rewrite secant squared s as 1 over cosine squared s. Aha, now I can see the cosine squareds will actually cancel, and I just am left with sine squared s over 1, or sine squared s. So this is where this is quite simple. This seems like we should be done. However, looking over to the right, I have cosine over there and nothing to do with sine. So now I need to think about an identity where I can rewrite sines in terms of cosines. So that's going to be another Pythagorean identity, which is sine squared s plus cosine squared s equals 1. So if I want to solve for sine squared s, because I'm trying to rewrite my sine squared s in terms of cosines, So this is kind of where you're thinking, your thinking bubbles going, I need cosines because of that. So if I subtract the cosine squared over, I get sine squared s equals 1 minus cosine squared s. Aha. So now I can go ahead, because I have sine squared s right here and right here, I can now say that this sine squared s is going to be equivalent to 1 minus cosine squared s. So I'm getting closer. Aha, I have my cosines, but it's not in this form. So is there a way to factor 1 minus cosine squared s? There is, in fact. So we can, anytime we have an expression which is like an a squared minus a b squared, we can factor that into an a plus b and an a minus b. So that means here that we can factor, since this is 1 squared and that's cosine squared, we can factor this into 1 plus cosine s and 1 minus cosine s. And the beauty is we have this is kind of our goal. And this is our map. So we're trying to map out our directions to get to the goal. But the beauty is when you're even here or here, you can look at that to see, oh, does this factor? Or can I factor this in any way? So once we get here, which is the right-hand side, we say, hey, we worked with only the left-hand side. We manipulated the left-hand side only and made it equivalent to the right-hand side. So we just proved that these two are equivalent to each other as long as s is in the domain of these functions. I hope you enjoyed this video. See you next time.